Di ba tapos na tayo dyan sa ano? Introduction?
Sir, ito po yung nabigay sa akin, sir.
Ganun ba? O, sige, sige. Sige. Okay lang yan.
Sige po. Palagay sa slide 1. Iron. Ayan, introduction in fluid mechanics. Ayan, definition. Fluid. Any substance which can flow, gases, and liquids po yung ano din, yung parang pinapoint. In fluid mechanics, all molecules should be in relative motion or continuously moving like water and gas. Other definition is any substance in which molecules are in relative motion can be known as fluid. Meaning naman po ng mechanics is the branch of science in which we study the about force and effect. Example, magnitude of force, direction of force. Next slide. What is fluid mechanics? The branch of science in which we study the behavior of fluids under the action force. Sa fluid mechanics po may three parts, which is fluid statics, kinematics, fluid dynamics. In fluid statics, the word statics it's at rest. Study of fluids at rest. In fluid kinematics, study of fluids in motion neglecting pressure, force. In fluid dynamics, study of fluids in motion considering pressure, force. Sa kinematics po, sa own understanding po, yung motion po is sa kinematics is hindi masyadong pinapansin and sa dynamics po, dun lang po siya parang, dun po siya kino-consider. Next slide. Next slide po. Properties of fluid mechanics. Density. The mass density or density of a fluid is defined as the ratio of a mass of fluid to its volume of the fluid. Density is called a mass per unit volume of a fluid. Specific weight. Specific weight represents the force exerted by gravity on a unit volume of a fluid. Specific volume. The specific volume of a fluid is defined as a ratio of the volume of fluid to the mass of fluid, or the volume of a fluid occupied by a unit mass or volume per unit mass of a fluid is called specific volume. The unit of specific volume is m cubed per over kg or kilogram, and this is commonly applied to gases. Specific gravity. The specific gravity of a fluid designated as Fg is defined as the ratio of the density of the fluid to the density of water at some specified temperature. Viscosity. Viscosity is measure of fluid resistance to flow. It describes the internal friction of a moving fluid. A fluid with large viscosity resists motion because its molecular makeup gives it a lot of internal friction. Next slide. What is friction? Friction is the force resisting the relative motion of solid surfaces, fluid layers, and material elements sliding against each other. The force that opposes the sliding motion of two touching surfaces. Next slide. There are several types of friction. Static friction. The frictional force resists force that is applied to an object, and the object remains at rest until the force of static friction is overcome. In kinetic friction, the frictional force resists the motion of an object. Sliding or kinetic friction, defined as a force that acts between moving surfaces. A body moving on the surface experiences a force in the opposite direction of its movement. The magnitude of the force will depend on the coefficient of kinetic friction between the two materials. Rolling friction. The force resisting the motion of a rolling body on a surface is known as rolling friction or rolling resistance. Rolling of ball or wheel on the etc. Fluid friction. Hindi ko makita. Fluid friction describes the friction between layers of a viscous fluid that are moving relative to each other. Next. Friction and viscosity. Viscosity resistance of a fluid, liquid or gas to a change in shape or movement of neighboring portions relative to one another. Viscosity denotes opposition to flow. The reciprocal of the viscosity is called the fluidity, a measure of the ease of flow. Ayan. Difference between solid friction and viscosity. Solid friction is independent of area of solid surfaces in contact. Friction does not depend on the velocity of the body. In viscosity is proportional to the surface area. Viscous force on the body depends on its velocity in the viscous media. Ayan. Tapos na po sa yun sa friction and viscosity.
Discharge. It is the rate of flow or the volume of water passing a cross-section of a stream in unit time. So makikita sa illustration, this volume of fluid, dito, pababa nga nung ano, the previous slide. Previous slide. Yung previous pa. Yan. Sa discharge. Dito. So the symbol Q will be used to designate the discharge in cubic feet per second or cubic meter per second. Other units of discharge, such as cubic feet per minute, or gallons per day, are sometimes employed for special purposes. So discharge is equal to volume over time. Next slide, please. We can change V to AD since volume is equal to area times distance. And we can change D over T to V since velocity is equal to distance over time. The different filaments of water move with different velocities. So it is common in hydraulics to deal with mean velocities. So now our formula is Q is equal to AV, where Q is the discharge in cubic meter per second or cubic feet per second. A is the cross-sectional area of flow in squared meter or squared feet, and velocity is the mean velocity of flow in meter per second or feet per second. Next slide, please. So sample problem number 1. A velocity of 3 feet per second is measured with a current meter placed above the bottom of a small stream. The estimated cross-sectional area of the stream is 3 squared feet. What is the estimated flow rate? So Q equals AV, substitution lang. 3 squared feet times 3 feet per second is equal to 3 cubic feet per second. Problem number 2. Complete, compute the discharge of water through 75 millimeter pipe if the mean velocity is 2.5 meter per second. So first convert muna natin ng 75 millimeter to meter. Then kunin natin yung area. 1/4 times pi times 0.075 meter squared is equal to 0.0044 squared meter. Ngayon pwede na natin makuha ang discharge. 0.0044 squared meter times 2.5 meter per second is 0.011 cubic meter per second. Problem number 3. A circular conduit has a radius of 2 meters. The velocity in the entrance profile was measured 4 meter per second. Calculate the discharge. So, katulad sa problem number 2, kunin muna natin ang area. Pi times 2 meter squared is equal to 12.57 square meter. Dito pa-hide yung ano. Hindi ko makita. So, kunin na natin ang discharge. 12.57 square meter times 4 meter per second is equal to 50.28 cubic meter per second. Next slide, please. Steady flow. It is one in which all conditions at any point in a stream remain constant with respect to time, or if the same quantity of water passes any cross-section of stream during equal successive intervals of time. May be uniform or non-uniform. So for example, kukunin ko ang velocity at point A and B. At first, at 0 minute, nakuha ko ng 1 meter per second sa point A at 2 meters per second sa point B. After a minute, kinalculate ko ulit yung velocity sa point A at sa point B. Nakakuha ulit ako ng 1 meter per second at 2 meter per second. After 2 minutes, kinalculate ko ulit yung velocities. At again, nakakuha ulit ako ng 1 meter per second sa point A at 2 meters per second sa point B. So, as you can see, pare-parehas ang velocity sa point A at pare-parehas din ang velocity sa point B. So, ito tinatawag na steady flow. Velocity remain constant with respect to time. Next slide, please. Uniform flow. It is one in which the velocity is same at a given instant at every point in the fluid. This condition requires a stream of uniform cross-section. So parang sa example ko kanina, calculate ko ulit yung velocity at point A at point B. At first, at 0 minute, nakuha ko ng 1 meter per second sa point A. At ganun din sa point B. Pareha sila ng velocity. After 1 minute, kinalculate ko ulit yung velocity. Nakuha naman ako ng 2 meters per second. At ganun din sa point B, 2 meters per second. After 2 minutes, kinalculate ko ulit ng velocity. Nakuha naman ako ng 3 meters per second sa point A at 3 meters din sa point B. 3 meters per second sa point B. So, ito yung tinatawag na uniform flow. Constant yung velocity at every point. So, makikita nyo sa 0 minute, yung velocity ng point A at point B pares na 1 meter per second. After 1 minute naman, sa 1 minute, pares naman silang 2 meter per second. At sa after 2 minutes, pares silang 3 meters per second. So magkakaroon lang ng uniform flow kapag yung pipe or yung cross section or yung area ay same size and shape. Yun lang po, next presenter.
Continuity of discharge in fluids. Next slide po. So yung continuity for fluids po is defined when fluids move through a full pipe, the volume of fluid that enters the pipe must equal the volume of fluid that leaves the pipe, even if the diameter of the pipe changes. This is the restatement of the law of conservation of mass for fluids. The volume of fluid moving through the pipe at any point can be quantified in terms of the volume flow rate, which is equal to the area of the pipe at that point multiplied by the velocity of the fluid. This volume flow rate must be constant throughout the pipe. Therefore, you can write the equation of continuity for fluids, or also known as the fluid continuity equation, as A1 V1 equals A2 V2. So yung equation po ng volumetric flow rate is derived din po siya sa equation ng mass flow rate. Ang difference lang po nila, yung sa mass flow rate po, meron pong involved na density of the fluid. Dito po, in terms of area of the pipe and yung velocity po ng fluid. Next slide po. This equation says that as the cross-section of the pipe gets smaller, the velocity of the fluid increases. As the cross-section gets larger, the fluid velocity decreases. You may have applied this yourself in watering the flowers in a garden hose. If you want to increase the velocity of the water coming from the end of the hose, you place your thumb over part of the opening of the hose, effectively decreasing the cross-sectional area of the hose's end and increasing the velocity of the exiting water. So yung sinasabi lang po dito is yung relation ng cross-sectional area dun sa velocity po ng fluid. Kung mapapansin niyo po, kapag yun nga po, yung sa example dito, yung sa hose po, kapag nililiitan po yung cross-sectional area nung endpoint po ng hose, bumibilis po yung velocity. Kasi po, inversely proportional po yung air. Hindi po, sir. Up no, sir. Mag-i-increase po yung velocity. Apo, sir. Next slide po sa example. So, meron po ditong question 1. Water runs through a water main of cross-sectional area 0.4 meters squared with a velocity of 6 meters per second. Calculate the velocity of the water in the pipe when the pipe tapers down to a cross-sectional area of 0.3 meters squared. Yung gagamitin po yung equation ng continuity of discharge na A1 V1 equals A2 V2. Direct substitution lang naman po ito. So yung given po dito na cross-sectional area is yung sa area 1, 0.4 and 0.3 po yung sa end. Then dividing po yung A1V1 sa A2, getting 6 meters per second. Yun po yung velocity at the end of the hose pipe. Next po. Water enters a typical garden hose of diameter 1.6 centimeter with a velocity of 3 meters per second. Calculate the exit velocity of water from the garden hose when a nozzle of diameter 0.5 centimeter is attached to the end of the hose. So yung first step po dito is kunin po muna yung cross-sectional area dun sa dalawang point since ang given lang po is yung dimension na 1.6 centimeter sa first po. And yung sa second diameter po is 0.5. Then i-convert po yung centimeters into meters para po mag-cancels out po yung meters per second tsaka meters. Magiging 0.008 times the pi kasi po yung area po na formula is pi r squared. Then magiging 2 times 10 to the negative 4 po yung area 1 and yung area 2 po is pi times 0.025 meters squared. 1.96 times 10 to the negative 5 po. Then next po. Then nakuha na po yung cross-sectional area at sa dalawang points po. Kaya pwede na po natin i-substitute directly dun sa equation of continuity. Area 1 times velocity 1 all over area 2. Then makukuha po natin yung answer na 30.6 meters per second. Then ayun lang po. Dito naman po sa streamline motion and turbulent motion. Diniscuss na po ito nung group 4 kaya daanan ko na lang din po. Yung streamline motion po, sa illustration po, meron po siyang parallel path nung particles of fluid with the pipe wall po. So straight line lang po yung motion niya. And nag-occur po ito sa very low velocity fluids. And oppositely naman po yung turbulent motion, yung fluid particles po niya without regularity and not in accordance with any laws. Kasi po, ayun po, dito po sa second bullet, yung pag high velocity po, yung mga movement po ng mga particles kung saan na po napupunta. Nagkakaroon na po ng high pressure dun. Next po.
Hello po. Next. So, yung una is yung energy. Yung energy is may two types. Yung energy is may two types. Yun ay kinetic energy and potential energy. So, basahin muna natin. Energy is defined as ability to do work. Both energy and work are measured in Newton meter or pounds foot in English. Kinetic energy and potential energy are the two commonly recognized forms of energy. In a flowing fluid, potential energy may be subdivided into energy due to position or elevation above a given datum, and energy due to pressure in the fluid. Head is the amount of energy per Newton or per pound of fluid. Next. So, ito po yung mga gagamitin nating unit is yung where is V is equal to mean velocity of flow. Yung unit niya is meter per second in SI and in feet per second naman in English. And next is yung P in fluid pressure. Ang unit niya is N over M squared or PA in SI. And LB or pound per feet second square or PSF in English. And yung Z naman is yung position of fluid or above or below the datum plane. Yung unit niya naman is M in SI and feet in English. G is the gravitational acceleration or 9.8 meter per second squared in SI and 32.2 feet per second squared in English. And yung Y naman is unit weight of fluid. Yung unit niya naman is N over M cube in SI and pound per feet cube in English. Next. So, kinetic energy and velocity head. Kinetic energy is the ability of mass to do work by virtue of its velocity. The kinetic energy of a mass, m, having a velocity of v, is one half mv squared. Since yung m po is, pag ano po siya, pag sinusolve po siya, yung equal niya po is w over g. So, yung formula ng kinetic is equal to w, yung m kasi ginawa siyang, pinag-iwalay siya, ginawa siyang w and g. So, pag kinonvert mo yung kinetic energy, yung magiging equation niya is equal to W times V squared over 2G. So yung para makuha mo yung velocity head, ililipat mo i-divide mo yung kinetic energy sa W. So yung ginawa dito sa equation na to is ano dinerive. So, yung velocity head is equal to kinetic energy over W. So yung kinetic energy over W is equal to V squared over 2 times G or gravity. Next. So yung sa velocity head of a circular pipes naman, the velocity head of a circular pipes of a diameter d following full can be found as follows. So para makuha mo naman dito yung velocity head sa circular pipes, yung formula niya is V squared over 2G. O yung V squared kasi, ano siya, yung V kasi, pag sinol mo siya, gagamitin mo yung Q over A or yung flow rate over A. So, yung dinerive dito is, yung dinerive dito, QA squared over 2G is equal to Q squared over 2G A squared. So, yung nakita mo yung ginawa dito, binaba yung A para, kasi pag sinimplify mo siya, pag ni-reciprocal mo, magiging Q squared over 2G A squared yung formula. So, para makuha naman yung yung velocity head, yung magiging pinaka final equation is V square over 2G is equal to Q square over 2G times 1/4 pi d square over quantity square. Or pag sinimplify mo naman siya is magiging equal to 16Q square over 2G times pi squared raised to d raised to 4. So pag isosolve mo na siya, pwede mong gamitin to kapag given yung pag gagamit ka ng direct substitution, magiging pinaka-formula niya is v square over 2g is equal to 8q raised to 2 over pi raised to 2 times gravity times dimension raised to 4. Next po. Next. So yung next is elevation energy and the elevation head. In connection to the action of gravity, elevation energy is manifested in a fluid by virtue of its position or elevation with respect to a horizontal datum plane. Elevation energy is equal to W respect to Z. Elevation head is equal to elevation energy over W para makuha mo yung Z. Next. Pressure energy and pressure head. A mass of fluid acquires pressure energy when it is in contact with other masses having some form of energy. Pressure energy, therefore, is an energy transmitted to the fluid by another mass that possesses some energy. So yung formula naman para makuha mo yung pressure head is gagamitin mo yung pressure energy na formula na is equal to W times pressure over Y. So pressure head, para makuha mo siya, yung pag dinerive mo yung pressure energy, yung pressure head is equal to pressure energy over W. So, yung pressure energy, i-divide mo lang siya sa W para makuha mo yung pressure head. Then, yung magiging yung pressure head is equal to pressure over Y. Then next po. So total energy of flow. The total energy or head in a fluid is the sum of kinetic and potential energies. Recall the potential energy are pressure energy and elevation energy. So para makuha mo yung total energy, i-add mo yung kinetic energy plus pressure energy plus elevation energy para makuha mo. So para makuha mo naman yung total head, pag i-add mo yung tatlong head, yun yung velocity head plus pressure head and elevation head. In symbol, the total head energy is E is equal to V square over 2G plus pressure over Y plus Z. Next. So, power and efficiency. Power is the rate of doing work per unit of time for a fluid of unit Y or N over M cube, following at the rate of Q times M cube over sec over S. With total energy of E or M, the power is what is power is equal to Q times Y times E, or efficiency is equal to output burst over input times 100. So yung note, 1 horsepower is equal to 746 watts and 1 horsepower is equal to 550 feet LD times over second, and 1 watt is equal to 1 newton m over second, or equal to 1 joule per second. Yun po. Next.
Bernoulli's theorem. Next slide, please. Introduction. Bernoulli demonstrated that in any steady flow stream, friction is neglected. The total energy contained in a given mass of water is equal at every point in its path of flow. The kinetic energy, pressure, energy, and energy of position may be converted into either of the two forms without loss. If there is a reduction of energy, there must be an equal gain in the other two. So in example, figure number one, points B, C, D, E is considered as a filament of flowing water. It has a steady streamline surrounded by other flowing water, same has the same velocity as BCDE. In this condition, friction is low, so we can ignore. Now, consider the forces acting on the filament BCDE. On the BC has an area represented as A1 with a normal pressure with the direction of flow represented as P1. On the section DE, it has an area represented as A2 and a normal pressure P2 parallel with and resisting motion. The forces at BD and CE is negligible since it has no effect on the flow, and gravity is acting downwards. Next slide, please. Now consider the time represented as dt. The water at points BC move to B prime C prime with a velocity represented as V1. Now at the same time, the water at DE moves to D prime E prime with a velocity represented as V2. Since there is a continuity of flow, uh, the equation is A1 V1 dt is equal to A2 V2 dt. Uh, Next is the work represented as G1. Uh, the work done by the forces acting on BC in the time represented as dt is the product of the total forces and distance which it acts. Magiging equation is G1 is equal to P1 A1 open parenthesis B1 dt close parenthesis. The unit is foot-pounds. Similarly, the work done on DE is G2 is equal to negative P2 A2 open parenthesis V2 dt close parenthesis. Same unit, foot-pounds. Note, P2 is negative because it is the opposite of P1 and it resists the motion of P1. Next slide, please. The work done by gravity on the entire mass from BCDE to B prime C prime D prime E prime is equal as moving from BC B prime C prime to DE D prime E prime, and the mass of B prime C prime DE remains the same. The gravity acting on BC B prime C prime is equal to the volume A1 B1 dt times the weight represented as W. If Z1 and Z2 represents the center of gravity for BC B prime C prime and DE D prime E prime above the plane MN, then the equation is G3 is equal to W A1 B1 dt open parenthesis Z1 minus Z2 close parenthesis. The unit is foot-pounds, or we can simply write the equation as change of U is equal to PG times the change of V open parenthesis Z1 minus Z2 close parenthesis same unit foot-pounds. The resultant gain in kinetic energy is m mv2 squared all over 2 minus mv1 squared all over 2 is equal to W A1 B1 dt all over 2G, open parenthesis V2 squared minus V1 squared. Or it can also be written as change of K is equal to 1 half times P times change in velocity, open parenthesis V2 squared minus V1 squared. Then from the fundamental principle of mechanics, we can write the equation as P1 A1 B1 dt is equal minus P2 A2 V2 minus dt plus W A1 B1 dt open parenthesis Z1 minus Z2 is equal to W A1 B1 dt all over 2G open parenthesis V2 squared minus V1 squared close parenthesis. Or we can simply write the equation as P1 minus P2 times the change in velocity is equal to 1 half times P change in velocity of times V2 squared minus V1 squared plus P times G times change in velocity of times Z1 minus Z2. Then dividing the equation will dividing the equation with W W A1 B1 dt and transferring the like terms to one side and remembering that A1 B1 is equal to A2 B2, we get the equation V1 squared all over 2G plus P1 over W plus Z1 is equal to V2 squared all over 2G plus P2 over W plus Z2. Or we can simply write the equation as P1 plus 1 half times P times V1 squared plus PGZ1 is equal to P2 plus 1 half times P G squared plus PG Z squared. Next slide, please. Next reporter.
Ah, so yun nga yung ano natin, yung Bernoulli equation na law of conservation of energy applied in flowing water. So, kapag nag-flow yung water natin from point 1 to another point 2, nababawasan yung energy niya dahil sa friction. So, dapat lamang na yung point 2, mas bababa yung value niya kaysa sa point 1. Kasi nga, nababawasan yung energy niya dahil sa friction. So, para maging balance yung Bernoulli equation, pwede natin siya isulat bilang as V1 squared over 2G plus P1 over W plus Z1 is equal to velocity 2 squared over 2 Z2 plus HF. So dagdagan siya ng HF. Ang nagre-represent is equal to the loss of energy. Itong equation na to, siya yung nagiging basis ng formula na ginagamit sa hydrokinetics. Next slide. So ito yung given problem natin. Water is flowing at rate of 2 cubic meter per second through a tube with a diameter of 1 meter. If the pressure at this point is 80 kilopascal, what is the pressure of the water after the tube narrows to a diameter of 0.5? So gagamitin natin yung Bernoulli equation. So dito sa problem, hindi nabanggit yung height difference, yung height interval. So pwedeng i-cancel na lang natin yung may mga height interval terms which is yung PG-C1 tsaka yung PG-C2. So marere-write siya as P2 is equal to P1 plus 1/2 times the fluid density times the difference between the velocities. So alam na natin yung initial pressure. So pwede na natin calculate yung kailangan natin i-calculate yung initial and final velocity. Kaya pwede natin gamitin yung continuity equation which is V is equal to V times the area. So yung gagamitin natin yung cross-sectional area. We can calculate yung diameter of the tube. So gamitin lang natin yung formula which is pi times the d squared over 4. So substitute lang natin yung mga given. Pi times 1 squared over 4 is equal to pi over 4. Tapos pi times 0.5 squared over 4 is equal to pi over 16. Meron na tayong given na nakuha na natin yung value ng area. So pwede na nating i-substitute do sa continuity equation which is yung V is equal to V times the area. So V1 is equal to 2 cubic meter per second over pi over 4 is equal to 8 over pi. Tapos dito sa isa naman sa velocity 2 is equal to cubic meter per second over pi over 16. So equal 32 over 5. Alin po, sir? Hindi po, sir. Yung isa po is 1 meter, yung isa po 0.5. Nakapasok na ba? Ito po yung pi, ito yung A1 is equal to pi d squared. Tapos, sir. So, nakuha na natin lahat yung value. Pwede nating i-substitute to do sa equation natin which is P2 is equal to P1 plus 1/2 times the fluid density times the difference between the velocities. So, yung fluid density natin is equal to 1,000 kilogram per cubic meter. So, by N lang, i-substitute lang natin yung mga given. So, makukuha natin is 76.2 kilopascal. Next, na presente.